Thank you, Chairperson. Assalamualaikum and a good day to the audience tuning into this presentation. I am Jasmine Cruz binti Muhammad Zaini, and today I will be presenting identifying suitable areas for plantation of organic products using GIS and AHP. According to Anand, the current trend of agriculture uses heavy amount of chemical fertilizers and pesticides. Hence, we should be promoting organic farming to the locals and farmers in Malaysia. What is organic farming? Organic farming is a cultivation method that is environmentally friendly because of the input of chemical pesticides and fertilizers are eliminated. This study uses analytical hierarchy process or AHP within GIS to define the weights and criteria that are selected in this study. The criteria will be explained furthermore in this presentation. Next, AHP is a tool that is often used for making decisions to identify suitable location for a specific activity. Next, the problem statement and the justification for this study. The lack of supply of organic products, although the demand is high from health-concerned consumers. Next, organic cultivation uses organic fertilizers, which lowers the yield due to a slower growth process. Next, farmers are not aware of the requirements for certification of organic land. Hence, although their land has potential for organic farming, they might not know it. Next, this study intends to identify suitable areas for organic farming in Sabak Bernam. And these are the objectives. To identify the suitable criteria for organic farming, to determine the weightage for each criteria, and to produce a map of suitable areas for organic cultivation. Next, this is the study area chosen. It is the Sabak Bernam district. This study area is chosen because Sabak Bernam is known for its agricultural nature. And these are the 7 criteria used within this study. These are the detailed requirements for organic land. It has to be, for a land to be classified as organic, it has to be far away from roads, and has to be near to drainage, has a slope of 0 to 5 degrees, high soil fertility or high organic matter, a flat aspect, and an elevation of 2 to 11 meters. Next, this is the overall methodology. For non-spatial data, questionnaires were sent to experts at MARDI using the concept of pairwise comparison or PWCM. For spatial data, 7 criteria are processed within the ArcMap software, which uses the site suitability model. Next, this is the sample of the questionnaire sent to MARDI. They received a sample of this questionnaire and also a tutorial on how to answer the questionnaire. Hence, this is the site suitability model that was done within the ArcMap software. The blue is the data. The yellow one is the tools, and the green is the output data. Next, we move on to results analysis. Out of 12 questionnaires that were sent to MARDI, 8 were answered, and these are the 2 examples of the questionnaires that were answered. Next, this is how I calculate the weightage within the QG software using the Easy AHP plugin. This is important because it calculates the CR. You can see here, CR is consistency ratio. Consistency ratio is important because it determines the validity of the questionnaires that were answered by the experts. These are the results obtained. This is the consistency ratio or CR. The CR has to be below 10% for the weightages to be valid. This is the average weightage for each criteria. Only 3 were selected because only 3 of them has a CR of below 10%. Hence, you can see from the average, soil fertility has a weightage of 44%, road has 17%, drainage is 14%, and etc. This is the weighted overlay tool within the ArcMap software, and these are the values filled within the tool to produce the final suitability map. To follow FAO's or Food and Agriculture Organization's standard, the sub-criteria, as you can see, these are the sub-criteria. They are categorized as 1, least concern, to 4, most concerned, which means they should be heavier in weightage. Next, this is the final suitability map. As you can see, most of the areas in Sabah Badan district are suitable for organic farming, which coincides with the nature of agriculture within the district. It matches up to 90%. And for the non-suitable areas, this is most likely due to land being too close to the road, and these are water bodies. This is the comparison between an on-ground site and a base map, the base map. A land that is highly suitable is within the forested area, you can see here. Next, a land that is moderately suitable, it is close to drainages, here, and far away from roads. Next, for a marginally suitable land, it is quite close to civilization, which means it is close to roads, and roads lead to air pollution such as smoke and dust. Finally, for a land that is not suitable, it is, as you can see here, for example, it is on a water body, which in general it's not suitable for crops. To conclude, this study utilized AHP with the integration of GIS to identify suitable land for agriculture within the district. Next, the ranks and weightages of its criteria were determined by experts' opinion and correlation analysis. Next, to further enhance this study, we could include more experts and a larger number of criteria within the map. Right, thank you.